Hello everyone, my name is James Burkhardt of JB Designers Manufacturing LLC. Today I will be covering Cura 5.1, basically how to download it and go over all the basic settings within for all you beginners that are out there. Let's get to it. Alright, so the first step that we're going to do is open up our favorite browser. I'll be using Google. And I'm going to type in ultimaker.com, and that's ULTI maker.com, and hit enter. Now we're looking at the opening screen here. What I'm going to do is just go up to the top of the screen until I see software, and I'm going to go down and then click Ultimaker Cura version 5.1. Once the screen pops up, you're going to go down here to the blue button which says download for free. So you're going to click that. And this is where you're going to choose the operating system that you currently have on your computer. So there is Windows, Mac for Apple computers, Linux, and also Linux Modern. I'll be choosing Windows. Now, as it's downloading, you're going to see this at the bottom left hand corner of your screen within your browser, or if you don't see it here, eventually it will pop up. You can get to your downloads. You can also find it there as well. I'm not going to actually go through the entire process of doing the download since I already have Cura, but I'll show you how to get to where you need to be. So go ahead and click it, and it's going to open up. A dialog screen should pop up. This application. I'm going to click yes. Then I'm going to click agree. Sure you know exactly where you want to be. If you want to edit this for your own purposes to put it somewhere else, you can. I'm just going to keep it to my program files, and it's going to download as Ultimaker Cura 5.1.0. Go ahead and click next. Okay, and it's going to give you your name here, the start menu, so we can find it. Just remember, it's not just going to be start with a C, we'll start with a U for Ultimaker. And you're going to go ahead and hit install. Now I don't need to hit install because I already have it downloaded, but you will be hitting the install button. Alright, so the next step that we're going to be doing is we are going to be opening up Cura. So I already have it pinned down on my taskbar because I use it quite frequently. But what you can do is then you can search for it. So put in Ultimaker, and sure enough, you will see it. Now I have two different versions put up here. One I've used previously, one I'm currently using, which is 5.1. I will be clicking 5.1. So go ahead and click that. Now for those who like to have shortcuts, go ahead and put a shortcut on your desktop background if you wish. I'm not personally a fan of them. I think they clutter my desktop up too much, so I keep them just pinned on my taskbar here. If you want to pin it, you can always just go to pin or unpin by clicking this button here. Okay. Alright, so we are in Cura. Now, for those who don't know or are new to 3D printing, Cura is what's known as a slicer. So, slicer, what that does, it converts an STL file into a printable file. Okay, so it converts it into what's known as G-code. The G-code then is put into your printer, whether it's by USB or other means. And what that does, the printer then understands that and then will start to print the item out. Okay. So, before we can get started though, we will have to set up a profile for a printer profile for your Cura. Okay. Now I'm going to use the example of an Anycubic Mega X. So I'm going to go here to this left hand side here where you see Alpha YZ20. It's one of my printers. Okay. So I have two printers set up already for profiles of Creality Ender 3 and the Alpha YZ20. What I'm going to do here is go to Add Printer. So if you're new and you're coming into this, you will be going here to Add Printer. So we're going to click that. Now, I'm not hooked up to a network. You may not be hooked up to a network either. Networked printers would be essentially connected to a local network that you may be connected to through the Wi-Fi or an Ethernet cable. But for many of you, you're not going to be in that case. So what you're going to do is come down here to where it says Add a non-network printer. We're going to click that. And we're going to scroll down to the printer that we want to install, or the profile we want to install. So we're looking for Anycubic. You can see that right here. And we're looking for the Max or the Mega X right here. Okay. And we're going to hit Add. Now, if your printer is not shown in here, you would go all the way to the bottom. Or actually, no, not to the bottom. You go to Custom, sorry. And then you will go to, then click on your custom printer, whatever, and then you'll be editing the settings for it. Bed size, printer height, that sort of thing later on. But we don't need that. We already know what our printer is going to be. So again, we'll scroll down to Anycubic, and we're going to click on the i3 Mega X and hit Add. What this will now do is put in a preset size for your build plate onto your screen. What you're seeing here is the limits to what your file can be printed within. Okay, so it shows you your size of your bed, which is this blue surface down here, and then the height, which is the top surface right up here. Alright, so let's go into the features of Cura. One of the first things I want to do is then, wherever you find your file from, okay? So you can go to places like Thingiverse, Colt 3D, those type of things. If you go to those sites, there's a lot of free offerings for files that you can download and then put into the slicer that you see here. Okay, so what you're going to do is you're going to go up to the file folder. You're going to click it. Now you don't see the window pop up, but what you would do is go to your files, and then you're going to find the file that you want. I'm going to pick a Pikachu that I printed for my son. I'm going to open it up. Sure enough, it pops up on the build surface. Okay. Now, depending on what the file size is, this one's fine because it stays within the build surface you see here. Sometimes, though, you'll get a file that's extremely too big. So let's say I put this at 1000% for scale, then all of a sudden, your Pikachu is way too big for the build surface. So we're going to keep this at 100%, and that's the scale button you see over here. I'm just going to hit enter, and it brings them back. Okay. Now, sticking with the scale button, see how everything changes? So if I change this to 50%, the Y and Z will also change to 50%. That's because uniform scaling has been selected. If I don't, and let's say we mess with the Y and make this 200%, it'll make the Pikachu look a lot longer. So that's why we normally, if you just want to make sure you scale it and it's uniform, we'll just keep the uniform scaling set, and then that'll keep it proportional to itself. That's how you resize the object. So we're going to keep this at 100, and hit enter. The move button is exactly what it sounds like. There's a couple ways you can make this thing move. So, for one, you can simply take your cursor, grab onto the object, not the blue, red, or green lines, but the object itself, and you can kind of shift it around and move it to wherever you want it to be. Okay. If you want to move it specifically in certain directions, let's say the X, Y, and Z, you will then grab what you want. So the Z is blue. So if I grab that, it'll move it up or down. Depends on what you want. Okay. Now, Z will automatically hop down to 0, and that's for a good reason. That means the lowest point of the print is touching the build surface. If it is not touching the build surface, let's say if the Z is 50, then it will be trying to print on air. Okay, and you'll figure out really quickly that printers cannot print on air. The Y is the green, so you can move that forward and back by simply dragging the green, or if you want to be more specific, you just put in the specific distance you want it to go. Same thing with the X, that is left and right. Okay. Now, when I say left and right, I mean that's relative to the home Z button. Okay, or the home button, or corner, I should say. Now, I'm going to go up here to view because I'm having a hard time seeing the corner here. I'm going to get a camera position, and I'm going to click 3D view. And sure enough, I see that corner now. And it shows this is where the nozzle of your printer will home to when you press the home button on your printer. Okay. So in relative, so the X and Y, the X would go left and right according to this corner. The Y front and back according to the corner, and the Z up and down. Okay. Next one is rotate, and as it sounds, you can rotate this file wherever direction you want. Okay. Sometimes you can adjust a file in a certain direction so that it prints in a more ideal situation. Okay. So for instance, let's say if you have a hard time, it will look better or be stronger in a certain position that you printed at, you would just adjust the turn like this by dragging a certain color, or the blue would turn it side to side, or the green also rotates like that. Okay. Now let's say you messed up. Let's say you wanted to put it back to its original spot. You can go up to edit and you can hit undo and keep hitting undo until it goes back to where it needs to be. Or we can try this. You have a couple options here. You reset, which will reset it exactly the way it needs to be. So if you click that, it'll reset. Also, if you click this, and let's move this forward like that, and we're going to click lay flat. Let's see what happens to this file. This might take a little bit to compute. Basically, the slicer is trying to figure out, well, what's the best way to lay this down so there's more surface touching the built plate. It might not work for this file. We'll see. Okay, so for this, it's saying lay flat, and that's the way it's going to lay. Well, this ain't going to work. So we're just going to hit reset, and we're good to go. Okay. The lay flat is good. It's to say if you have like a print that has flat surfaces, and so that they would lay perfectly flat onto the build surface. Mirror. This is what happens when you mirror. So if you do this, it will print or switch the object in the mirrored position that it is. It doesn't flip it or like rotate it. It will actually print it in its mirror image. Okay, so this is the mirror image of this Pikachu. And then, so that's helpful if you need to print, let's say, two pieces that connect to each other, and they're halves of a piece. You can do that by simply doing a mirror of it, and then those two pieces should come together easy enough. Per parts model, that's only used if you actually have multiple parts on the build surface, or let's say multiple items on the build surface. You can have certain settings for each one of those. And then this is a support blocker, and we're going to talk about supports in a second. Actually, right now we can talk about it now. So if you look at the file, you're going to see stuff in red, right? And those things in red mean that they need supports. Okay, because like I said before, we cannot print on air. So if we tried to print, let's say, the chin of the Pikachu here, it will droop extremely when the nozzle tries to print that area. Either that, or it will just completely fail, and then it will never build. So we need to have supports underneath those to keep the things up so they can continue printing in the direction it needs to go. Sometimes, though, you don't need supports. Like this arm here is probably at like a 45-degree angle. The printer will be able to print this no problem. Okay? It's the flat surface, like underneath the chin, that's going to be a problem. Or underneath the legs here, that might be a problem. Or the nose, or whatever. Those need supports. But there's places that don't need supports. Let's say the arm here. Then what we'll do is we'll put up these support blockers, and that will prevent the file from, or the arm from getting supports, because sometimes supports give a rough surface look under on the part that it was supporting. So if you think that the printer is going to be able to print the object with no supports, then you put the support blockers in place. You can add or remove these simply by clicking the support again and double clicking them. It'll make them disappear. Okay? So those are the 6 settings that you see on the left hand side of the object. Alright, let's take a look at the top here. We talked about the printers already. One of the nice things about when you have these different profiles set up, let's say if I want to put this on the alpha eyes, if you just click that printer, it'll automatically import your file onto that new or the other printer. And let's say if I want it on my Ender 3, it'll set it up on the Ender 3. Now, do keep in mind the settings for this, which I'll talk about in a minute, will change according to what each printer is preset to. So just keep that in mind. Go back to Anycubic. Okay. Now, we're going to look at the top here, and we're making our way over to the right. Right now, all the way at the top here, sorry, we got Prepare, Preview, and Monitor. Okay. Prepare is used for what we see here. That's what we've been using this entire time. Preview is when we actually slice the object, which we'll talk about later when we have the settings where we want them to be. And monitor, if you have this hooked up to your printer directly, so you can monitor the print as it's printing. Okay, that's if it's up to a network or whatever else. But mainly these two are the most important: prepare and preview. Okay, so here it says generic PLA. For those who don't know, PLA is one of those types of plastics that the printers can print. There's many different types. So let's take a look at some of the types here. So Gufu makes a ton of them. So you can see here we got ABS, ASA, HIPS, PA, PC, PEEK, PETG. So we got a bunch of different types of plastics. Each one of these plastics has a very specific temperature, specific way of printing, specific settings that are needed. That's where this becomes important. So these are your filament profiles that you can save. Okay, and this becomes important when you start printing, with many different types of filaments and brands of filaments, because you want to make sure that the the filament is supported by the settings that it needs. So if we know that we're going to use PLA, and we're going to use eSuns PLA Plus, we can select specific colors. Some profiles have those. And then that will save all the settings that we do to this. So if we go over here to our settings and change this, it'll automatically save to this setting for the best settings that you have. And then whenever you, let's say you print with a different filament, 2 days later you want to print back to this, the eSuns Black, then you just go up and select that filament profile, and it'll bring up all the settings attached to it. Okay, so this be you may or may not use this. I personally don't use it too often because I use pretty much the same brands all the time. But if you're one of those that uses many different types of filaments, and you find that there's quite differences between them all, go ahead and use this option. Okay. Now, over here is your settings. Okay, this is one of the most important things when it comes to making sure that your print is set up correctly. Okay, so when you click on this tab, it's going to bring down a window underneath. And what I'm going to do is, if you click on these three little lines, it's going to give you what the setups are going to look like for this. We have the basic setup. For anyone that's starting out, this is the perfect one to use. It'll give you the very basics of what you want. Advanced is going to give you a few more options to pick from, and Expert, pretty much all the options to pick from, and Edit, and that sort of thing. Okay, we're going to start with the basic setups. Okay, the first thing we're going to look at is quality. Now, quality means how smooth this object is going to be. Now, 0.2 is pretty good. Okay, it's not the best in the world. If I pop it down to 0.15, it's going to be more detail. 0.1, even more detail. Okay, 0.08, even more detail. What that does is each layer now is shorter, and that allows for gradual more detail throughout the print. And you don't see the layer lines as easily as you would if I pop this up to 0.35. Okay, and that will increase the layer lines in general. Okay, let's slice this real quick so I can show you what those layer lines would look like. So first of all, we have this at 0.35 height. You see that the hour, how long it's going to take for this to print, 3 hours and 41 minutes, just by adjusting the height. Let's see what happens when we pop it down to 0.15. Okay, it's smaller layers. Let's see what happens when we slice. Alright, now, this print now will go on for 8 hours, not 3.5 like the other one, but 8 hours. And that's because if you make the layers smaller, it will take longer for it to print. So, keep in mind, you want the delicate balance. If you want something to print fast, you're going to have to print bigger layers. It's not going to look as good, but it will be faster. Okay? Now, if you're doing figurines, like let's say Pikachu here, and you want the most detail out of it, make it smaller layers. Okay. Now, if we get a preview, you get to see how this print is by layers. So, this is how the this is how the 3D printer works. It will print by all the layers. So you can see here, that's the bottommost layer, the second layer, third layer, so on and so forth. So it shows how it builds up. previewing your print before you you print is pretty important, because this gives you a good idea if anything's going to fail if you're printing. Let's say if you forgot to put a support in or whatever, you'll see that. And a couple things you see in the preview here. You see the infill. Let me get above it. The infill's a grid. You can see the walls. It looks like 3 walls supporting this for these lines here, these green lines coming in. So 1, 2, 3. Okay, so those are your walls. Let's go back to prepare, and that's where it comes down here where it says walls, wall thickness. So wall thickness is important because this will determine basically how strong your model is going to be around the outside edges. Okay, so what this does is it takes your nozzle size. So the nozzle for this machine, again, is 0.4 millimeters, and then it multiplies the size of the filament that's coming out of the nozzle by a certain amount. So 0.4 goes into 1.2 3 times. Okay, if I adjust this number to 4, it'll ignore this wall thickness, and it will do it 0.16 or 1.6. Okay, so you can do it that way, adjust this number, or you can put in the thickness that you want, and then the printer will be accommodating for that. Okay, but walls are important. Sometimes, let's say for this Pikachu model, you can have it at 3 walls, and the inside with an infill, which we'll talk about in a minute, with a low number, and it'll be just as strong. Okay. Don't worry about the horizontal expansion. As you can see, you can look more into this, or to get more information about it, if the little hover over the item and the black box pops up. Okay. Top and bottom thickness. This is important because if you don't have enough thickness on the bottom or top, you'll start to see through the object, and you'll see the infill or the inside of the object when you don't want to. Okay, so top and bottom thickness is in direct relation to your layer height. Okay, so if your layer height is 0.15, if you take that and divide that in, if you take 1.5 and divide it by your layer height, which is 0.15, it'll give you 10 top layers. This is a lot. I don't say it's necessary to have 10 top layers. I would think you could probably hop it down to 6, if not lower than that. But what you want, if you want at least 4 to give you good coverage. If you have very small layers, then going up to 6 is probably better. Same thing for the bottom. You want to have enough layers on the bottom as well. Okay. Your infill. This is what's going to happen inside. Now you may be tempted just to print everything at 100%. That is not good. Okay, especially for like figurines that we see here. You do not need to print this at 100% because it's not like a structurally sound. It's not a print that needs to be structurally strong. It's just going to be an aesthetic looking one. It could be a play toy for a kid or whatever it is. You know, having a infill density of 25 is going to be pretty strong. If I were doing this as just something that sits on a dresser or something like that in a kid's room for just to look at, I would pop it down to 5% infill. Okay. The only time I would use 100% or 50% to 100% infill is if I'm doing something that needs to be structurally strong for whatever reason. Okay. Let's say a bracket to hold up something. I would print that at 100%. The infill pattern here, You can have it whatever pattern you want. They're pretty much all fairly strong. If you have a different pattern that you would like to see, you can select these, and this is what prints on the inside of your object. Okay, so we have the grid. You've seen the grid before when we sliced it. Let's slice it again so you can see. Okay, preview. There's the inside. So before you saw the little tiny squares, that was 25% infill. This is 10%. There's a lot of wide opening spaces. Now here's the drawback to having low infill. Obviously strength. The other thing is when you're doing your top layers over these areas, if your printer does not do a good job of cooling the filament and keeping its shape, it could droop inside these wide open holes. Okay. Now printers nowadays work pretty good, so they're able to span across distances and surprise you. So kind of work with those settings. You're gonna have to play with those as you're doing prints and see which settings work best for you. Also, a benefit for doing low support on the inside, or low percentage, is it prints much more quickly. Less filament being used, which means it's not making as many movements, and it's going to print more quickly. So that's infill. So again, you can set your pattern. Let's say if we want to do cubic, I'm going to slice that, and I'll show you what that looks like. Okay, and cubic gives a different design on the inside. All right, and you can see how that design progresses by simply moving this line up and down, so you can see how everything prints, or what the layers are for the print. Okay, so again, what you see in green and red, those are your walls. The red actually shows your shell, or the outside edge. The inside lines here that are in orange, that's your infill. Okay, now material. So we're looking at temperatures to print at. So this is you can usually find the temperature settings for each one of the filaments on the actual spool. Okay, and it'll tell you what the minimum and maximum temperatures are, or guidelines for that. A lot of times when you're printing, you'll kind of figure out what the sweet spot is for basically all that same type of filament, such as PLA. I typically print at 220 to 225. Okay, but your printer might be different, so you might have it at 215 instead. And again, all filaments do print differently. They're made up. Their plastics are made differently. Processes are different. So you got to be careful about that. Then you got your printing material. So if you set this, I usually do about, like I said, about 220. And then your build plate temperature. This is also important for the type of filament that you're using. Typically for PLA, I keep it at about 50. If I'm doing other filaments, such as drawing a blank. ABS, sorry. ABS requires a higher temperature, nearly 90 to 110 Celsius, in order for it to keep its adhesion. So that's the important part of build plate temperature. That keeps the print stuck to the surface. It helps keep it stuck to the surface and helps prevent what's known as warping. Warping happens when the corners of the print start raising off the surface before the print is done, and that could cause aesthetic issues as well as stability issues. So again, look at your filament types, make sure you have the right amount. So if I'm using PLA, I typically hit at 50. If you put it, let's say if you're printing with PLA and you put it at 90, then you will actually melt and deform the print as it's printing, because the build plate is way too hot. So make sure you have the right temperatures for that. Now your speed. Okay, so depending on the type of printer that you have, there will be a maximum speed that it can print at. But do keep in mind the very basics of this. The lower the speed, the better quality. Simple as that. Okay, so 50 is an okay speed. If you want to get better quality, you would pop it down to, let's say, 30 millimeters per second, and it should print more cleanly. Um, One of the reasons why we just make sure we understand what the print speeds are. We don't want the printer to, it's known as skip steps, if it's going too fast, and it might cause layer shifts, or issues like that. And once you get into the printing of stuff, you'll start to see these things and you'll understand why. But keeping it at a low speed, you should be good. Okay, so 30 to 50 is a good speed to be printing at. If you want better quality, something that's going to print for a while possibly, and you want the best quality print you got, lower it down to 25 or 20. Okay, retractions for travel. Now, retraction happens, you want this to happen, you want this set. So when the nozzle moves from one place to another, when it's not putting out filament, it might ooze some filament or have a little bit hanging out of the nozzle, and it might impact the print. So enabling retraction allows for you to for the printer to suck in the filament when it's moving from one place to another, okay, and then spitting it out when it's over the print where it needs to start printing. Z-hop is important. Let's say if you have a lot of supports or parts in the print that are in line with the nozzle and they rise up slightly, the nozzle might hit those parts as it's traveling across the print. So the Z-hop, what that does is it raises up a set distance after it's done printing, moves to where it needs to print next, and then drops back down. Okay, that helps prevent it from knocking into the print so it doesn't dislodge it. So that's traveling. Cooling. Now, this is probably one of the important parts of the for the printer as well. In order for the print to keep its shape, and especially for those more difficult angles it needs to print, cooling needs to be on. So fan speed is going to be represented by percentage. So if you want it to be maximum, you hop it up to 100%. If you want it to be minimum, you would hit it 20. If you're printing with ABS, you'll actually have this exactly at 0 because ABS filament does not like heat, or cooling, sorry. Loves heat. So just keep that in mind, the type of filament you're using and what's the best type of cooling for it. Okay, so typically I always keep these at 100 if I do need the cooling. The next thing is supports, and this is where it gets interesting, to say the least. Supports needed because printers can't print on air. Okay, it's as simple as that. So I already showed you the red marks underneath the chin and the arms. Those mean that they're unsupported, and they will need supports if they're not blocked. So for supports, we will be going to, I'm going to click this, and there's two different placements for supports: touching build plate and everywhere. So touching build plate means specifically for anything that's overhanging the build plate, it will have supports rising up from the build plate up to that point. If there's something in line, let's say if the arm of Pikachu was over top the leg, because the bed is underneath the leg and the arm is right above it, it would not give it supports because it's only doing things that touch the build plate. Okay. Now, if I do, let's say if the arm is over the leg here for Pikachu, and I want supports underneath it, then I would click everywhere. The only issue with everywhere is it will put supports everywhere, and supports can be somewhat difficult to take off. And though if they're printed in a way which will sit on top of the actual print, it might cause some aesthetic issues, making it look bad or whatever else. The overhang angle, let's say, so if you hover over this, it'll tell you. It says the minimum angle of the overhang for which support is added. At a value of 0, all overhangs are supported. At 90, it will not provide any support. All right. So what that's saying is about 50% of all the overhangs will be covered. Okay. So if we hop it up to 75, that means you can see the red has disappeared on the print. Let me go back to a more favorable view here. Now, what that's saying is, well, there is really no spot here that needs to be covered. Let's look at from the bottom view. You usually see where red is. Sure enough, there's only one spot on Pikachu. If I put it at a setting of 70, that would need support, and it's right under its rear end. Okay. Just because you edit this number doesn't mean it's going to print correctly, even if you set it at that number. So if I set it at 75, doesn't mean it might print correctly, and you have a lot of confidence in your printer's overhang abilities. But you may want to just put in the supports to assist it. So if you want more supports, you put in a lower number. As you can see, more of the model is shown. That's not necessary. There's parts in there that will print perfectly fine without that. So find a sweet spot, put it in, and then you should be good. Now, there are different types of supports that you can use, and we'll go over that. You'll use the more advanced options to do that. But for now, these are going to be vertical supports that come up from the build surface to connect to points that need to be supported. Build plate adhesion. So this becomes important when your model starts popping up from the build surface, and you want to kind of give it more surface area for it to stay down. There's a few different options here. One is a skirt. Okay, the skirt simply puts a line around the object. Okay, this line doesn't do much for adhesion. Okay, what it does is it will it gives you an idea when it's printing if the nozzle needs to be lowered or raised when you're trying to get the sweet spot for where the nozzle should be at the start of the print. Okay, a brim will give it a border to print around, and I'll show you what that looks like with when I slice it. Let's get a preview. What this does, it gives it more surface area around the edges, and we'll kind of keep it planted to the build surface. So you can see here all the little lines that popped up around his legs, around the supports, and that's what you would see. This is what the supports look like, by the way. These are what are called tree supports, as they curve around the object and connect. It looks like Cura 5 does not use verticals as default, so that's pretty cool. But yeah, you can see everything supported. You see the tails being supported, the ears being supported, the mouth is being supported, the chin is being supported. Yeah, it looks like this would be successful. I don't see much of an issue with anything not getting the support that it needs. Okay, but this is what you see for bed adhesion. You see the many layers coming out from the surrounding surface of the Pikachu. Now, the next one is a raft. This is if your build surface just is not flat enough, It might have some ripples in it. Let's say if you're using a magnetic bed that's old, you might want to do what's called a raft. And what that does, it prints a bed for the print to be printed on top of, to allow for the print to adhere to the bed in hopes that it doesn't pop off or is able to adhere and be fine. So that is a raft. The drawback to a raft is it wastes a lot of filament. Okay, it depends on how well you know, or how thick you want the raft to be. Okay. Now the dual extrusion button, you will not have, unless you have multiple nozzles or multiple colors that are connected, or a nozzle that's capable of printing multiple colors at once. You're not going to worry too much about this setting. And that's basically it for the basics of printing. So once you have all your settings in place and you're ready to print, you're going to hit the slice button. We'll wait for that to slice. Okay. Now you put in your SD card. Okay, the card that you need to save your files onto. There we go. Right now the option is save to disk, and what that does is allows you to save to your computer or whatever you want. Okay. By the way, if you get this, your SD card says ask you to format, just ignore it. Okay, should be fine. Now, as I'm looking at the SD file here, I can see that there's already some files on here. These are what's called G code. Okay. Now, what I'm going to do, save to removable drive. If you don't want to save it to the removable drive, you can just save to the disk. You just click on that option and that'll bring it up. But I want to save to the removable drive, and I'm going to hit save. Okay. Now, just to check to make sure all is good, cancel here. Let's take a look at our SD card, make sure it's saved to it correctly. Sure enough, it's on the file now, and it is a G-code file. Now you should be able to put this right into your printer as is, whether you need to take the mini SD card and plug it into your printer, or use the card adapter to plug into your printer. Either way, it should. Okay, so that's going to conclude today's video on Cura 5.1, the basics. Hopefully that was informative for some of you that need that further assistance on how to use the slicer and how to use Cura in general. In future videos, I will be going more in depth with some of the expert settings, so just keep an eye out. And if you have any questions, leave a comment below, and I'll try and answer them as quickly as I can, and as thoroughly as I can. I do appreciate that, and even with things such as how the videos are shot and stuff like that, please do. Thanks for watching, and I'll catch you on the next one.